In this we discuss LeetCode problem 3219 and also the 3218 also. Minimum cost of cutting cake 2 and also 1. Okay, 3218 also. But okay, both are actually same and constant are different. Okay, so there is an m cross n cake that needs to be cut into 1 cross 1 pieces. Okay, you are given two given integers m, n and two in arrays. What are the two arrays? Two arrays is a horizontal cut and the another is vertical cut. And size of the horizontal cut is m minus 1, where horizontal cut I represent the cost to cut along the horizontal line I. And vertical cut of size is n minus 1, where vertical cut j represent the cost to cut along the vertical line j. Okay, so in one operation, you can choose any piece of cake that is not yet a 1 cross 1 square and perform one of the following cuts. What are the operation I can actually do? One operation I can do cut along the horizontal line I at a cost of horizontal cut I. Or I can cut actually the vertical line j at a cost of vertical cut j. Alright. After the cut, the piece of cake is divided into two distinct pieces. Okay, the cost of a cut depends only on the initial cost of the line and does not change. So I have to return the minimum total cost to cut the entire cake into 1 cross 1 pieces. Okay, so let's see the example 1. There is a m is equal to 3 and n is equal to 2. So m cross the cake size is 3 cross 2. So 3 row are there, 1, 2, 3, and 2 column are there, right? So they mentioned that what are cost to cut horizontal cut 1 and 3. So first horizontal line cost is 1, second horizontal line cost is 3, and this first vertical line cost is 5, right? So what is the way I can actually cut this cake into 1 cross 1 pieces? First of all, I can cut actually this horizontal line basis. Okay, then what is actually possible? The cake will be look like this and this, right? So now cost is for this cost is 1, right? Now suppose I want to cut this along this horizontal line. Okay, so what is the cake look like? So this will look like in this way, this three row. Now what is the cost? Cost is 1 plus this 3. For this cut I cost is 1, and for this cut I cost is 3, right? Suppose now I want to cut this along this this vertical. Okay, so what is the cost of this? Cost will be this will be look like this. For this also it will be into two pieces. So cost is 1 plus 3 plus how many actually vertical line will be there? 1, 2, 3. So 3 into cost is 5, right? What is the logic, right? What is the cost? Why it is 3 into 5? Because there are 3 rows actually are there, and I am cutting one vertical. So for this cut I need 5 cost. For this also I need 5 cost. For this cut I also need 5, right? So what is the total cost? 15, 18, 19, right? So can I optimize this? Let's try another move. Like first of all, I cut this with this vertical line, along this vertical line. So what will be the cake look like? This will look like this, right? So what is the total cost? Total cost till now 5. Now suppose I want to cut this with this horizontal line, first horizontal line. So what is the total cost? 5 plus 1 into how many vertical what is the block are there? 2. So till now cost is 7, and cake will look like this, right? Now I want to cut this with this horizontal line, second horizontal line. So what is the cake will look like? This. So what is the cost now? Previously it was 7 plus how many actually it will cut this whenever I cut this horizontal line basis. So there are 2 actually cut, and what is the cost? 3. So total actually cost will be 7 plus 2 into 3, 6, 13, right? Got it, right? So this is actually less than 19. So our current answer will be 13, right? So in this actually we have to try all the possible way. Then actually I can actually choose what is the minimum cost, right? So one observation actually you can actually check, like whenever you're doing any cart. So like here actually what is the maximum cart actually, what is the maximum cost to cart? Between 1, 3 and 5, because maximum cost is 5. So if I have to minimize the cost to cart, then what is the way to cut actually? Like try to use minimum number of times this cut, then try to use this cost as much as less as possible, right? Like first try to use this cut as less as possible. Then I have done all the like one observation is that every cut will have been needed, right? Because you can actually check, like because like for this cut, whenever I suppose first of all I cut this vertical line, then I cut this horizontal line. Then I used these two cut always, but suppose then I used first I cut on horizontal basis, then I cut on the vertical basis. So in this case also I used both this cut horizontal and vertical, but order is different, right? So or I have to use all the cut to make the cake as the pieces 1 cross 1. So it is sure. So somehow I have to use the maximum cost as small as possible. This actually minimize our cost, total cost. Like here actually, if I suppose in this way the 5 cost is maximum. Okay, suppose I divide all, like here actually I divided all the row basis. Horizontal cut I have done. So first of all I have done this, then I have done this. So if then I am calling this vertical cut, then what is the cost? It actually contributing to the total cost. 5 into it is cut only 1, 2, 3. 5 into 3, 15. But suppose if I cut this at the first, then first I did the vertical cut, then actually I am calling the horizontal cut. Then what is the contributing? 5 will contribute to the total cost. 5 into 1, right? It is always less than 15. What the logic? If I did all other cut first, then I call the vertical cut, then what is the total cost contributing to the total cost? 5 into 3 here in this case. And if I call the vertical cut first, then I call all other remaining operation, then what is the total cost it contributing the total cost? 5. Got it? What is the logic, right? That's why I have to first of all call the maximum cost as early as possible, because otherwise it will contribute, because it will minimize the total cost. Got the logic? Now I have to understand how it is like here actually how many actually were contributing. 5 into 3, and here actually we are doing 5 into 3, 5 into 1. So suppose for this matrix 1, 2, 3, got it. Now initially how many actually horizontal block are there? Horizontal block is 1, vertical block also 1. Got it? Now suppose here if I called vertical cut first, this, so it's actually how many like how many actually it will actually multiply with how many actually it will multiply, like cost is suppose C. So it will contribute C into number of horizontal are there, because this horizontal is only one horizontal there, that's why C into 1. Got it? Suppose after cutting this, what actually our cake will look like? This cake will look like this, right? So in this case actually how many actually horizontal there? Horizontal is still 1, because suppose if I call this, suppose there is one more column, then actually it will be easy. Suppose this, there is one more column there. I call the vertical cut here, so that's why our cake is look like this. Now suppose here I want to call this vertical cut first line. Okay, then how many actually it will actually call? With how many? Like for this it will actually call for this one, actually for this one and for this one. So it will check how many actually vertical block are there. This is one vertical block and this is one vertical block, right? So that's why the cost of suppose h1 for this horizontal cut 1 row 1 cost is h1. So how many actually h1 into 2, got it? And for this it was c into 1, suppose c1, this will be easy to understand, c1 into 1, got it? Now after cutting this, okay, the graph was actually initially look like this, so I cut this. So how many actually vertical actually done? 1 increased by 1 is 2. Why vertical is 2? Because I have cut this one vertical partition and this is one vertical partition, but horizontal is still same. Now after cutting this horizontal line, how actually the cake look like? This will look like this. This will look like this, got it? Now how many actually horizontal are there? How many horizontal are there now for this graph after cutting this? How many? You should check after calling this, you will actually understand. Suppose I want to call this this column to column cut, okay? So how many actually this cost will multiply column 2 c2 cost 2, and was there how many actually horizontal are there? For this actually this is 1 and for this actually I have 2 columns, so this is actually 2, right? So after cutting this horizontal line, they are also increased of horizontal line 2, so this will be horizontal plus 1. So whenever you are calling any horizontal cut, so you got the got the logic, right? That whenever you are calling any horizontal cut, number of horizontal block is increasing by 1. Why increasing by 1? Because there is 2 partition are there. It's actually partitioning, right? There is one partition 1 and this is one partition 2. Initially it is one partition and now it is 2 partition, that's why it is increased by 1, right? So whenever you're cutting any horizontal cut, our horizontal block will be increased by 1. And when we're calling any vertical cut, then our vertical count will be increased by 1, got it? Because they are also partitioning in 2 parts, right? So, and whenever doing any horizontal cut, how actually cost are contributing in the total cost? Like here actually you can check, like whenever doing any horizontal cost h1. So with how many actually horizontal cut you need? How many vertical partition are there till that time, right? This is actually how many particle, because I am calling this horizontal cut. So this will actually cut this in this way. So there is this one vertical partition, this is one vertical block. So this will be 2 verticals, that's why it's contributed to 2. So that's why it will multiply with number of vertical blocks, got it? Whenever doing any horizontal cut. Now whenever doing any column cut, suppose this we are calling in C2, this column. So how does cost is, I know that cost is C2. So how many actually it will contribute in the total cost? How much? It will multiply with 2. Why? Because number of horizontal block, because there are 2 horizontal block for this one horizontal block and this actually horizontal block 1. Got the logic? And I have said all the observations, right? Now go to the code, actually it will be easy. So first of all I have sort the cost with respect to decreasing value, both horizontal cut and vertical cut. I said why actually I have sorted this, because I want to take maximum cost as small as less as possible, because I have said that if I call the 5 cut vertical cut at the end, it will contribute into the total cost as 15. But if I call at the beginning, the total cost is contributed as 5. It will actually minimize our total cost. Got it? So that's why I have sorted this in the decreasing order. Okay. Now first of all check what is the column, what is the vertical cut or whatever actually the minimum value, like vertical cut or horizontal cut, whatever actually minimum, whatever the maximum, sorry, that I will take initially, and I will cut this cake on the basis of that, right? And here actually order is no matter, because ultimately I will call all the cut, and ultimately cake will be look like 1 cross 1. So I sorted this, and now I found out what is the length of these two cut. Okay, now initially there are two pointer L1 and L2. This L1 is pointing to this horizontal cut, and L2 is pointing to this vertical cut. Okay, so initially our horizontal block is 1 and vertical block is also 1. Got it? Like the cake is look like this, right? Now I'll check. Now traversing till I have actually both comparable. Like both the matrix, both the array is still not reached end. Okay, so I'll check what is the either in range L1 and L2. Both are less than L1 and length 1 and length 2. Then I'll check what is the maximum cost between these two pointer. I'll check what is the horizontal cut for this particular index L1 and what is the vertical cut for this particular L2. If horizontal cut is greater than vertical cut, then what will I choose? I will choose horizontal cut because it will actually contribute less in the total cost. That's why I will choose at the beginning. Okay, so how much actually to contribute total cost? Like what is the cost each one, and how many actually vertical block are there? Okay, got it. And after cut, I have actually said how actually its horizontal block are increasing. Like if I cut this horizontal line basis, suppose this horizontal line basis, so there actually these two partition are there. Got it? That's why horizontal block will be increased by +1, and also I increase the index L1 plus because I have already cut this horizontal cut on this row. Now if it is our horizontal cost is less than vertical cost, so first of all I will choose this vertical cut. So what will how much actually contribute after vertical cost into number of horizontal block are there, and after cut I will increase the vertical block because I have already mentioned this graph is look like this. Then if I cut this column basis, then the matrix will look like this. Got it? And L2 plus because I have already cut this, so I have taken this. Go to the next cut procedure. Okay, now I have reached suppose any one of the array at the end to the end. Okay, now I will check. I have already mentioned that I have to take all the cut because otherwise it's not possible to cut as 1 cross 1 matrix. So I will check which array is not till at the end. I have to take this cut. So I will just add the cost horizontal cut this particular index cost into number of vertical blocks, and I will increase the horizontal blocks. It does not need actually, but it's okay because for logic actually you can actually understand that yeah, after each horizontal cutting the horizontal block will be increased by 1. Got it? And also you increase the index also. And similarly if it is vertical cut is not in the end, then I have to take this cut currently. So whatever the cost and the number of horizontal block, I will take into multiply this and add into the cost, and I will increase the vertical block also. Got it? And also increase the index, and at the end return the cost. Right? So what is the time velocity of this? So I am sorting this array. So this will be m log n suppose, and this will be n log n. And I am here traversing suppose each index only once. So time velocity will be big of m plus n. This while loop. So time velocity will be m log m plus n log n plus m plus n. So it will be actually m log n or something. Got it? And any space complexity? No, we are not using any new extra space. So that's just space complexity big of 1. What is the logic, right? You can also solve this with the 3218 problem also. The problem is same but constant different. Okay. Also understood the logic, right? Thank you.